Chapter 6, Probability. 6.1 is all about simulations. What is a simulation? A simulation is imitation of chance behavior. It's based on a model which, in short, accurately shows what are the real possibilities in a problem, what are the outcomes under consideration taken. Some examples include flipping a coin, rolling a die, the random number generator on the calculator, and the random number table, like table being or pink packet. Steps include, so step 1 is that you want to state the problem, then you want to state the assumptions, then you want to assign digits to represent the different outcomes, and then you want to simulate as many repetitions as possible, and at the same time look at the average of the occurrences, like looking at the number of occurrences that you're looking in the problem. And step 5, summarizing the information and drawing conclusions using, for example, the actual probability. Practice problem, trying this one out. So the first one is stating the problem. So we state the problem as what's the likelihood of at least getting 2 girls out of 3 children. Then you want to state the assumptions, which is that boys and girls are equally likely, and that each girl or each child is independent of one another. Then you want to assign digits to represent the different outcomes. 1 is boy and 2 is girl. And then 4 is you want to simulate many repetitions. In this case, we did 25 using the random number generator on the calculator. We set the rand at 1 and then did rand int 1, 2, 3. Then we highlighted the ones that have at least 2 girls out of 3 children, and that came out to 15 over 25 to 60%. And then you want to compare it with the actual probability, which is 50%, because getting a girl from girl or boy is 50%. And that just means that if you do more and more repetitions, your actual number that you got 60% will be closer to the theoretical number of 50%. 6.2 is about probability models. The first slide tells you all the vocab that's needed. So random just means that individual outcomes are uncertain, but there is a regular distribution in a large number of repetitions. In short, you can't actually say what's next because of the large distribution of the outcomes in number of repetitions. Probability is the number of times the outcome would occur in the long run. It's like a long-term frequency. Then the sample space is a set of all possible outcomes. An event is any outcome or set of outcomes of a random phenomenon. It's a subset of sample space. The probability model is a mathematical description is very important, of a random phenomenon consisting of 2 parts. First is a sample size, and second is a way of assigning probabilities to events. And examples of assigning probabilities to events is a tree diagram and a Venn diagram. The next 2 bullet points are very important in math or in probability, especially because and that just determines the probability of a particular event occurring. It's important to understand if it's with replacement or without replacement. The name of it is self-explanatory, but just that with replacement means that when you pick out something, an object or like a card or something, it goes back into the sample space, and it's not replaced. You replace it, but it goes back in it. So yeah. And then without replacement is when you pick up an object and it you don't put it back, you don't replace it. And then some rules include the multiplication principle, which just means that n1 times n2, where n1 is the number of ways to task 1 and n2 is the number of ways to do task 2. When you multiply both of them, that equals the number of ways you could do both tasks. And then the probability rules include the first one's that the probability of event A occurring is between 0 and 1 inclusive. It can't be more than that. It has to be in that range. Then the next one is that the total sample space probability equals 1. When you add all the probability in a sample space, it must equal 1. The addition rule for disjoint events. Before telling you what it is, it's important to understand what mutually exclusive or disjoint mean. They both have the same thing. They're events that can't occur at the same time. Like, for example, cross country and soccer. These are events that you can't, like in MHS, you can't play them at the same time in the fall. So they're mutually exclusive and disjoint, same thing. So the rule for that is that P, probability of event A or event B occurring, is the probability of event A plus the probability of B occurring. And the diagram on the right explains that they're totally different like events. So like that's why they have different circles of them, and that's why when you add them, that just tells you the probability of either A or B. And the complement rule just means that probability of the complement of A equals 1 minus the probability of A. Complement of A just means that if I'm like drinking juice versus I'm not drinking juice, like it's like that. And then more rules is for like the important thing is like about the notation. Union means or. I always think as union has an unit, and the symbol for union is similar to a U. And intersection has an and in it, and if you write and in capital letters like the A is similar to the symbol for intersection. So that's how to remember it. Independent events is the occurrence or non-occurrence of one event does not change the probability of other event occurring. And disjoint events cannot be independent. Multiplication rule for independent events is that probability of A and B equals probability of A times probability of B. And that's only possible if and only if A and B are independent events. Probability of at least one event occurring is the probability that it doesn't occur minus it. So 1 minus probability of none. And the practice problem for that would be using deck of cards. So what's the probability of choosing 2 cards and both are red, and you do it with that replacement? So the first probability of choosing first card which is red, is 26 out of 52 because there's 26 red cards in a deck of 52 cards. That times the probability of 25 over 51 because it's for that replacement, and that's why you get rid of one card from one red card, and that's why it's 25 out of 51. And it's multiplication because it's an and problem, like intersection and that's why it's 625 over 262,652, which equals 0.2357. Second one is the probability that first card is a heart, replace it, and then second card is the king. So this one explicitly tells you that it replaces it, and there's an and problem. So you would find, there's 13 hearts in a deck of 52 cards, so 13 times 52, replacing it, so 52 stays the same, and then there's 4 hearts in a deck of 52, there you would do 4 over 52, and you multiply that, and it's 1 over 52.
6.3 probability rules. Union, the set of all possible outcomes that lead to one or more events occurring. The general addition rule for a union of any 2 events is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. An example of this is the probability that Miss Safer will give Lily an extension on the next lab is 0.7. The probability that she'll give Dylan an extension is 0.4. The probability of both Lily and Dylan getting an extension is 0.25. So PA is 0.7, PB is 0.4, and PA and B is 0.25. Conditional probability gives the probability of one event occurring under the condition, given that another event already happened.
The thing you guys see between A and B, like the mark, just means that A, like, given B already happened. So probability of A, mark B is the probability of A given that B occurs. And probability of B mark A is the probability that B given A occurs. That just means that, like, B already happened, and what's the probability of A occurring? Or like A already happened, and what's the probability